All right. So we've got a list of, we've been sort of developing a relationship between the function and its derivative and what integration is, the movement from the derivative function to the original function. So what we're going to do now is we've just got a list of rules and we're just going to use these rules to come up with the answer for the integral. So I've listed a few of them here. I haven't listed all of them. They're in the book there. We'll pop up or point them out as we're going along. Okay. Now, probably one property I need to point out. We've got properties of integrals, okay, listed halfway down the page there. We've talked about why we've got plus c. Now, the second property we've already addressed. We talked about that in the first part of the lesson today. But the first property, all right, which says we have the integral of f of x plus g of x. It's just equal to the integral of f of x plus the integral of g of x. All this means is just like differentiation, how we differentiate term by term, we differentiate every term, just means we integrate every term separately as well. So we'll have a direct application of that rule up here. So I'm going to do this in a really long drawn out manner to illustrate all of the properties that we're using. And then I'll show you what steps you would need to answer this question. Really, this is a 1 mark question, so it's not that there's process involved, it's just the answer we're interested in, but I'm going to draw out the process for you. So first, we're asked to integrate this function, all right? Now what that means, if we're going to break it down, it means we have to integrate each part of the function. Okay, so we're integrating each part of the function. Now, anytime we write the integral statement, we need to write our dx's to say we're integrating with regards to x. And then all I'm going to do as well is just apply, so that all I've done there is apply our first property of integrals. And then I'm going to pull the numbers out the front. So here we have 4 times the integral of x. And we can even, like, minus 1 is a number, we can pull that out the front. We have to take away 1 lot of the integral of 2 with regards to x. Okay, so we've got this component, we've got this component, and we've got this component. I might just spread them out a little bit more. So plus, and then take the integral of 2 with regards to x. Okay, so now let's just look at the rules and apply the rules. If I have x to the power of n, all right, x to the power of n, the integral is x to the n plus 1 on top of n plus 1. And we pointed this out on Friday afternoon to try to make this relationship. So I have x to the 3, which means my integral is going to be x to the 4 on top of 4. Okay, n plus 1 on top of n plus 1. All right, we'll take that power, 3 plus 1 is 4, on top of 3 plus 1. So that's what the first component goes to. Then we have, just like calculus, this number 4 is just hanging out. It's got to multiply whatever the integral of x is. Okay, what's the integral of x? X by itself is x to the power of 1, isn't it? So it's x to the power of n, and so we're just applying this rule, 1 plus 1, 4x to the power of 2 on top of 2. Okay, so with x to the 1, we have 1 plus 1 on top of 1 plus 1. All right, then we have take away, and we're going to go, what's the integral of 2? Well, the integral of k is kx. So the integral of 2 will be 2x, and then we'll put our plus c on the end. Okay, so I've done this in a sort of long, drawn-out way. It can be simplified as well, or written in a number of different ways. Like we could express that component like that. 4 times x squared on 2, that would simplify to 2x squared. Okay, because we basically have 4 times a half. We have take away 2x and plus c. Okay, so we don't need this step, all right? All I'm doing is pointing out, we integrate term by term. We don't need this step. All I'm doing is pointing out, we can pull the numbers out the front. You get full marks here. Okay, 1 mark question, full marks are occurring there. We're just applying the rules to the 3 parts. Okay, let's do example B. I definitely don't have enough room there, so I'll do it here. We have the integral of the cubed root of x, take 4e to the x. So my very first step, just like differentiation, is express everything as x to the power of n. So if I have the cubed root of x, that means x to the power of a third. Okay, so that's the first part. And then we have take away 4 lots of e to the x. Okay, so we're asked to integrate this. All right, so we're going to just do it in one step. We're moving from here to our answer. All right, so we have x to the n, okay, x to the n, so we're applying the first rule. And maybe we'll do it in 2 steps. I'm going to write up here a third plus 1 on top of a third plus 1. If you want, you can do it in one go. You don't need to write it out like that, but I'm just illustrating x to the n plus 1 on top of n plus 1. Take away the 4 is going to hang out, just like calculus. The numbers, the coefficients just stay there. Take away 4. And then we go, what's the integral of e to the x? So we can just refer directly to our table here. All right at the top, 4e, if we have a function, the antiderivative, the integral of it is e to the x plus c. So the integral of e to the x is just e to the x. Okay, so that component integrates to this, that component integrates to this, and then we'll just chuck our plus c on the end there. Okay, now the textbook won't present it like that as the final answer. They'll say, okay, if I have a third plus 1, that's the same as 4 on top of 3, on top of 4 on 3. And then they'll do A on B, on C, on D. Basically, the bottom number is going to come to the top. So we'll have 3x to the power of 4 on 3 on top of 4. All right, so the x to the 4 on 3, that's the power. And the 3 at the bottom is coming to the top. All right, so that's B. We'll have room for C here. We have the integral of 3 on x plus 2 times 1 on x squared plus sine x with regards to x. Now, we should always express everything as x to the power of n at the top of the fraction, except when we have only one lot of x at the bottom, okay? And that's because the integral of 1 on x is ln x. If you try apply this rule, you're going to end up with a power of 0, okay? So what we've got here is we've got 3 times 1 on x. We've got here 2 times x to the minus 2, and then we've got sine x. So I'm expressing everything in a manner conducive to integration, in a manner ready for us to recognize the rules that apply, okay? And then we're just integrating term by term. So the integral of 1 on x is ln x. So this part goes to 3 lots of ln x. Okay, here, the 2 just hangs out, that's a coefficient, and we're integrating x to the power of minus 2. So x to the n, so we would have x to the minus 2 plus 1 on top of minus 2 plus 1. All right, and then we'll look at our sheet here. The integral of sine of x is negative cos x. And then we'll chuck out plus c at the end. We only need 1 plus c. Okay, to simplify it then, we have 3 ln x. Here we're dividing it by minus 1, so that's just going to make this part negative. Take 2, x to the minus 1, or we can express the x at the bottom, 2 on top of x. Okay, that's what that part is going to. Take away cos x, and then plus c. Alright, so just applying the rules to each separate part. So that's the first question. Let's move on to the second question. In the second question, we've just worded it a little bit differently. Find the antiderivative of the following with respect to x. So what that means is integrate this function. So, term by term, 4 is just going to hang out. Integral of cos x is, look at our worksheet, positive sine x. Okay? Integral of, take away, integral of 3, 3x. Alright, integral of k, kx, integral of 3x, and then plus c. So that's the first one there. All right, b is going to be a little bit more involved in both b and c. Okay, now if we're asked to integrate this, we obviously need to simplify it first because it's expressed as a quotient. So the first thing we're going to do is split the denominator. All right, so we're just going to maintain equality by splitting the denominators of both terms. So this is a skill we did in calculus. All we're saying is that if we have 3 plus 1 on top of 4, that's equal to 3 on 4 plus 1 on 4. We're just splitting it up into two fractions. And now we can express both parts as a single power of n. Like this here, x to the 1 times x to the half, that part simplifies to x to the 3 on 2. And then we'll just do the top power, take the bottom power. So 3 on 2, take away 2. That's going to just leave me with x to the half. All right, so if I do it's going to be minus half, sorry. 1.5 take away 2, that leaves me with minus half there. And then over here we just have take away 3 times x to the minus 2. So all we've done, like we did this in calculus, okay, is we've just maintained equality, that this function is equal to this function is equal to this function, and now we're at a place where we're ready to perform the integral of it. Everything is expressed as x to the power of n. Everything is at the top of the fraction. Let's apply the rules of integration. Integral of x to the n, just applying the rule. All right, integral of x to the minus half is going to be x to the minus half plus 1 on top of minus half plus 1. All right. Take away the 3's just hanging out, the numbers just hanging out. Okay, the integral of x to the minus 2, that's going to be minus 2 plus 1 on top of minus 2 plus 1. Plus c, and then we'll just simplify it a little bit. This is minus half plus 1 will be x to the half on top of half. This will be minus, I'll leave the minus 3, we'll do it in a couple of steps, x to the minus 1 on top of minus 1, and then we have plus c. Now we have square root of x divided by a half, okay? If you do your a on b on c on d, that 2 is just coming to the top. We've got 2 root x, that's what that part is. And then here we've got negative and negative, that's going to become positive. And 3, we've got x to the minus 1, so we can write it as x to the minus 1, or we can take the x to the bottom as 3 on x. Either is fully correct. All right, so full marks there. Okay, last one. We've got 3, but we won't go through that just yet. The integral of x take 2 squared. Now, we don't know how to integrate a function to the power of n yet. We will learn a rule for it tomorrow or Friday, but for now, we're just going to have to expand it and then integrate term by term. So we'll perform the perfect square expansion. Okay, so we're just maintaining equality between the two functions, and then we'll just integrate term by term. Integral of x squared, x to the 3 on 3. 4 is just hanging out. The integral of x is x squared on 2. And the integral of k is kx. So integral of 4 is 4x plus c. So simplify a little bit. All right. So we've done a few complex ones up there. They're probably a little bit trickier than the textbook starts off. So I would like us all to make a start on 4E.1. All right, so yeah, let's just see how we go. Develop a bit of confidence in applying these rules. That's our plan for today. It says differentiate this and hence find the integral of this. So the first thing we're going to do is differentiate this. We have to use the product rule, all right? Because we have one function multiplied by another. So u is x, u dash will be 1. V is sine x, and v dash, the derivative of sine x, is cos x. Okay, let's mash all of them together. When I differentiate this, the answer will be u dash v plus u v dash. Okay, so what have we done so far? We've said if I differentiate this, this is what I get. So now what we're going to do is make an integral statement. This is always the case. Ignore what they're asking you to get for now. Let's just make the integral statement. If I differentiate this, I obtain this. Therefore, the integral of this, okay, the integral of this component equals this. All right, now we're very close. We are asked to find the integral of x cos x, which means they just want to know what's the integral of this part. We don't have a rule to integrate a product, so we're going to have to perform some manipulation here. Now, one of the properties of integrals is that we integrate term by term. So I'm going to separate the integral. And now it's just a linear equation. We're interested in this component of it. So I'm just going to subtract that from both sides. I'm going to move that over to here. We have the integral of x cos x. X sine x is hanging out. And I'm subtracting that from both sides, the integral of sine x. Okay, we're almost done. This we can perform. We know what the integral of sine x is. It's negative cos x. So the integral of x cos x with regards to x is going to be x sine x, take away negative cos x. So that becomes plus, and then we'll put our plus c right at the end. Okay, so let me talk you through the whole process. What do we do? We differentiate, we make the integral statement. This is the crux, this is sort of the foundation of solving the problem. If I differentiate this, I get this. Therefore, the integral of that is this. We just write that as a statement. Now, we're interested, it wants us to solve for this part. So we split the integrals, we integrate term by term. I want this part by itself, okay? I'm trying to get this all by itself. I'm going to subtract that from both sides. I've moved it over. And then in my last step, all I'm doing is performing the integral of negative sine x. Okay, that will be enough for you to now finish off 4E.1. Try your very hardest, see how you go. Make sure you're comfortable with the rules. And we'll catch up with you on Friday.